All right, today we are diving headfirst into a really fascinating clash of worlds. We're talking about a collision between the simple, everyday logic that we all live by and the completely bizarre, totally counterintuitive rules of quantum physics.
So let's just start with a question that feels like it breaks reality. What if that one fundamental rule, the absolute bedrock of how we think the universe works, cause and effect, what if it isn't so fundamental after all?
To really get a handle on just how weird this is all going to get, we first have to plant our feet firmly on the ground. We need to talk about the familiar world of classical causality. That's the rulebook we all use every single day without even giving it a second thought. This is basically the logic of falling dominoes, right? It's so simple and satisfying. One thing happens, which makes the next thing happen, and so on, in a nice, predictable line. It's intuitive, it's reliable, and honestly, it's the foundation for pretty much all of science. This whole rulebook is built on a few core ideas that just feel like common sense. First up is locality. Things can only be affected by what's right next to them. No spooky action at a distance. Then you've got determinism. You do the same thing, you get the same result every time. The arrow of time, it only points one way, forward. And reality itself is just there. It exists on its own, whether we're looking at it or not. Okay, but here's where it all gets turned on its head. When we zoom way, way down to the tiny scale of individual particles, that neat and tidy common sense rulebook, it doesn't just get bent, it gets completely torn to shreds. The very first rule to just shatter is locality. In the quantum world, you can have two entangled particles separated by huge distances, but when you measure one, the other is affected instantly. This is what Einstein called spooky action at a distance, and it just completely breaks our classical intuition. And the next rule to go? Determinism. See, in our world, if you know all the details, you know what's going to happen. But in the quantum world, nope. It's replaced by pure, uncut randomness. You can never know for sure what a particle will do. All you can do is calculate the odds.
So the bottom line is, the quantum world is playing a completely different game with a totally different set of rules. It's non-local, it's random, the person doing the observing can actually change the outcome just by looking. And get this, some interpretations even suggest the future can influence the past. It's a whole new ballgame.
Now, this massive conflict isn't just some weird little quirk. It's one of the single biggest unanswered questions in physics, and it's launched this huge global quest to figure out how in the world can we build a bridge, a single unified theory that connects these two completely different realities. And this is not a simple problem with a simple solution. Right now, scientists are attacking this from every angle you can imagine. We're talking at least a dozen major distinct approaches, each one trying to draw that single unified map of causality that works everywhere in the universe. These different ideas generally fall into a few main camps. Some researchers are trying to stretch our old maps, like flowcharts, to fit this new weird territory. Others are basically saying, forget the old maps, we need brand new tools. So they're tracking the flow of information itself. And then you have the most ambitious folks who are trying to draw a completely new map from a blank piece of paper with none of our old assumptions. Okay, so probably the most mind-bending of all these new ideas is a framework that allows for something called indefinite causal order. I mean, just think about that for a second. It means the very sequence of events can exist in a quantum superposition. It's not A happens, then B happens, and it's not B happens, then A happens. It's somehow both at the very same time. And look, this isn't just some wild science fiction theory. Scientists have actually built and demonstrated this exact thing, a quantum switch in the lab. They've literally proven that our simple common sense idea of a fixed one-way timeline, it just doesn't apply down at the quantum level. So this is so much more than just a philosophical puzzle that hurts your brain to think about. This whole quest could fundamentally change our world. Yeah, this is not just a debate for physicists in ivory towers. Understanding the real rules of quantum causality is absolutely essential for developing the next wave of technology. We're talking more powerful quantum computers, unbreakable cryptography, more precise atomic clocks, the whole shebang. So the big takeaway here is that by mapping out this bizarre new territory, we're not just solving some deep cosmic mystery. We are literally building the foundation we need to truly unlock and harness the immense power of the quantum world and build the future. Which leaves us all with one final, pretty provocative thought to chew on.
is that most fundamental rule we know, cause always comes before effect. Is that really a law of the universe? Or is it just a local habit, a convenient illusion we've gotten used to in our little corner of a much larger, much stranger, and honestly, much more amazing reality?